Ladies and gentlemen, today I would like to present my research in the topic of rapid technique for curcumin and moisture content determination in turmeric powder using FT-NIR. Turmeric or curcuma longa is the flowering plant and has been utilized as a spice, herbal medicine, and ingredients in the cosmetic, especially in Thailand, Asia, and the Middle East. The turmeric rhizome with a characteristic deep orange-yellow color, known as turmeric, is a very important ingredient in curry and widely used as coloring and flavor agent. Curcuminoids are one of the major components of the turmeric, which are responsible for the orange-yellow color. Particularly, curcumin has demonstrated powerful efficacy as an anti-cancer agent with process anti-inflammatory, antioxidative, anti-Alzheimer, and anti-cancer activity in both preclinical and clinical study. Turmeric oil is also widely used in pharmaceutical and cosmetic applications. What are the research problems? We know the moisture content and the active substance of herb powder are very important for quality control and pricing. Moisture content determination of herb powder normally use oven method and dielectric measurement. These are destructive methods, take long time, and touch sample directly. The active substance determination of herb powder normally use the DNA fingerprint technique or chemical substance determination by HPLC are now is used and can provide a very precise result, but it has a major drawback. The operation cost, chemical reagent, take time, and sample detection. How to solve this problem? Non-destructive technology, for example, light and sound, and near-infrared spectroscopy or NIRs. What is near-infrared spectroscopy? Near-infrared is a light, the wavelength about 700 to 2400 nanometers, and there are 5 modes for the scan the sample. The first one is transmittant, and the second one is transfectant mode. The third one is the diffuse transfectant. The fourth one is interactant, and the last one is transmittant through scattering medium. What happens in the biomaterial molecule? NIR effect on OH, NH, and CH function, and present in terms of the spectra and in the term of the absorbance, show the spectra. Many information inside in NIR spectra. Different spectra present different chemical inside the biomaterial. For example, the red line is the spectra of oil, the green line is spectra of starch, and the blue line the spectra of rice. Different material and spectra show difference. How to calibration equation procedure. calibration and validation equation were developed by using spectra data and chemical data, and then the base calibration equation was used to routine application for prediction the chemicals data. Previous research Lee et al. Study on the characterization of herbal powder blend homogeneity using near-infrared spectroscopy. Kim et al. Study on near-infrared spectroscopy as a rapid and non-detective analysis tool for curcuminoid in the turmeric. And Lohmi et al. The study on the detection of starch adulteration in onion powder by FT-NIR and FT-IR spectroscopy, and Saputi et al. The study on infrared spectroscopic feature of turmeric powder. However, this is no available public study regarding the use of FT-NIR for predicting the moisture content and curcumin in the turmeric powder. So the objective of this research to study the determination of the curcumin and moisture content in turmeric powder by rapid method using FT-NIRs, which will bring benefit in the turmeric trading and processing in the future. Research method: sample preparation for the moisture content determination. Turmeric powder for herbal shop was used and dry in the oven method at the 45 degrees Celsius. The sample randomly separated to the 4 groups were dried for 0 to the 180 minutes, and total of the 60 samples were used. 5 duplications of each sample were kept in the plastic bag, and moisture content of sample were measured by hot air oven. The sample were kept in the instrument laboratory at the temperature is 25 degrees Celsius. And the same this is a method for the curcumin determination. Turmeric rhizome were harvested every 7 days for 5 months, including 76 samples of a total rhizome were cleaned, cut, and dried at 50 degrees Celsius for 12 hours and grind to the powder, and 5 duplicates of each sample kept in the plastic bag. Samples were analyzed for curcumin by HPLC method. The samples were kept in the instrument laboratory room at temperature about 75 degrees Celsius. Spectra acquisition equipped with plastic bag sample holder in defectant mode were used to measure the NIR spectra in the region of 1000 to 2500 nanometers. The resolution used was 2 nanometers, with the average number of the scan at 32 charm. This figure shows the FT-NIR spectrometer. Data analysis: the unscalable version 10.1 were used to perform the data analysis by partially square regression analysis. This figure shows the original spectra of the turmeric powder, present important absorption band. You can see the number one shows the aromatic band in the length about 1143 to 1210 nanometers. And the second number shows we call water band. the wavelength about 1450 and 1470 nanometer. The result of the data analysis, this table shows the PISR calibration and validation result for the predicting the moisture content and curcumin in turmeric powder sample. You can see the calibration equation show R square very high in moisture content determination, about 0.92 and show 0.98 for curcumin determination, and in validation equation show very low bias, about 0.0 of both moisture content and curcumin determination by FT-NIR. And you can see scatter plot for moisture content determination by FT-NIR. The calibration and validation scatter plot show very relationship between actual moisture content and predicted moisture content. You can see as very high R square, about 0.9 in both calibration and validation. And the same result for curcumin concentration determination, show very high relationship between actual and predicting value. R square show 0.98, same both of calibration and validation. In conclusion, the development measurement system with high accuracy without sample detection with FT-NIR spectrometer with plastic bag sample holder in defectant node should be used. PIS regression was used to develop equations from the original spectra, was a good system for determining the moisture content and curcumin in the turmeric powder. FT-NIR technique as non-destructive measurement will be the benefit for the turmeric powder quality control and trading. Acknowledgement, this research was fully supported by the Center of the Research and Quality Analysis of Good Using Non-Destructive Methods, Faculty of Engineering, RMUTI, KhonKaen Campus, Thailand. Thank you for your attention.